Hi everyone, this is Sharan here. Today in this video, we are going to see a simple implementation of random forest algorithm. In one of the previous sessions, I have explained the concept behind the random forest algorithm, like why it is called random forest, what type of scenarios we can use random forest, when we shouldn't use random forest, what makes random forest so special that it outperforms a lot of other algorithms, and what is the specialty of random forest, how it ensures that the trees that are being built are not correlated with each other. If you have any questions or if you want to understand those concepts much better, I will link the video in the description. You can go through it and then you can understand the concept behind the random forest algorithm. But in today's session, what we are going to do is we are going to see a simple implementation of random forest for a classification problem, and I'm also going to share towards the end some of the learning material that you can use in order to understand the concepts much better. So watch this video till the end so that you don't miss any of the concepts or any of the learning materials that I am going to share in this video. So first, let's get into the implementation. Like as you see in my screen, so the first step is to import all the packages that is required. So before running this, I'm going to clear all the output. So now it's all cleared. So what I'm going to do is I'm going to import all the packages. The first one is Pandas, because the dataset that we are going to read will be in the data frame format. So Pandas, and then what we are doing is we are going to use model selection, like the test train split, which will be used to split the dataset into test as well as training data. And so stlearn is the package, and we are going to use random forest classifier. Why we are using random forest classifier? Because we are going to solve the classification problem. And the next one are packages and libraries that are related to measuring the accuracy of the model, like confusion matrix accuracy and ROC AUC store, which also one of the ways to measure, like to see how good the model is performing, like based on the prediction that we are able to get. So now we have imported all the packages that is required. If you get any error at this step, it means that any of those packages are not installed properly. So you need to do the installation, and then you can come and then proceed with the script. The second one is we are going to read the dataset. So the dataset that we are going to use today is same as the dataset that we have used in the recent past. Like the dataset to predict the heart disease. We have various features, and then we are going to predict whether a particular person will have a heart disease or not. So I'm going to read this particular dataset. The source of the dataset is also provided here, which I will provide it in the description as well. So now we have read the dataset and it is in the data frame format. Now the next step is like as usual, like I'm going to remove all those NAs. So we can have NAs, like random forest will be able to handle it, but here just for simplicity case, what I'm doing is I'm just going to remove all those NAs from the dataset. So now we have removed the NAs. So now the next script here, I'm going to separate the dependent variables as well as the independent variables. So I'm using this ILOC functionality to separate it. So let me execute it. So now we have separated like the dependent variables and the independent variables. So then what we are going to do is we are going to divide it into a training data set and test data set. So generally the training data set will be in the range of maybe 70% to 80%. So here in this case, what I'm doing is I'm saying like 80% should be training data and 20% should be test data. So let me execute this and then divide it into training and test data set. So this is how the names of the data frames would look like X train, X test, Y train, and Y test. So now next I'm going to initialize the random forest classifier algorithm. So this is how I'm going to initialize it. So n estimator equal to 100 means that the upper threshold, like the number of trees that is going to be built is 100 different trees. So let me execute this as well, and then now what I'm going to do is I'm going to fit, like I'm going to use the training data set and then fit the model so that it can be used to make the prediction. So let me execute this, and the next one is I'm going to make the prediction. So I'm going to use model.predict, which is very same as a lot of other algorithms as well, and we are going to use the X test and make the prediction for it. So now what we are doing is like there are two steps here. Like one is the predictions here will have the actual predictions, like whether there is a heart disease or not, and then RF probability will have the probability. So if in case you don't want to use the prediction, what you can do is you can go and then use the probabilities and then maybe change the probability according to your needs, and then hence the prediction also changes. So for time being, I'm just going to use as it is. I'm not going to make any changes. So in order to show you how it would look like, so let me just copy this here, and then when I execute it, so as you see here, so all these are probabilities. So instead of RF probs, let's say I'm going to use RF predictions. So when I execute this, so what happens is, so this is the actual prediction, so it will be 0 or 1, like as per the data set. So that's the difference between these two. So here in this case, I'm reading the probability as well, because we would want to use it in order to check the ROC like area under the curve value. So now here what we are going to do is we are going to see the actual test data, like what was the actual output, and then we are going to use the probability to calculate the ROC area under the curve. Like the larger the area under the curve, it means that the better the algorithm, like better the prediction are. So let me execute this, and what is the ROC value? So the ROC value in this case is 0.71. It means that it is quite good. Like if it is 1, it means that we are able to make the prediction 100% accurate. If it is 0, so then our model is 0% accurate. We are not able to make even a single correct prediction. So our objective should be to move the ROC value closer to 1. Like if we move closer towards 1, it means that our model is performing really well. So next one is we are going to use the other techniques like the confusion matrix as well as the accuracy to store in order to see how good the model has performed. So what we are going to do is we are going to see like what was the prediction that we made, what was the actual values in the test data set, and we are going to compare it and then see the results. So let me execute this. So as you see here, so this diagonal here, those are the right ones, like the true positives as well as the true negatives, and the more the value that falls into this particular bucket here, it means that the better the model is, and the overall accuracy is over 83%. So the model has been quite good. What we haven't done is we haven't done any feature engineering. Like if you are interested in feature engineering, right? Like I have covered like from day 1 to day 50. I have covered various concepts like what are all the various functionalities of Pandas, NumPy, how would you do the exploratory data analysis, how to visualize various data. So those are all the various concepts that helps you to understand the data much better, and then to do various feature engineering and then do some modifications to the data, add new features to it. So if you are going to make use of all those knowledge, what you can do is you can do some feature engineering, improve the data set that you are having. Instead of directly using the data set that was provided by Cattle, you can use it and then you can modify it. You can include some more new modified features, and hence what happens is the prediction also improves along with it. So here in this example, like my objective is to show you how to implement a random forest algorithm. But in reality, like in practical situation, if you're going to compete in an Untitled competition with a lot of other people, what you need to do is you need to work on the feature engineering part. Like in any data science problem, 80% of the time would be spent in feature engineering, like in understanding the data, doing various analysis and transforming that in order to make it more suitable for the algorithm that we are trying to use. So that by that way, what we can do is we can improve the algorithm. The other method is there are various hyperparameters for each algorithm. So we can tune those hyperparameters, like changing the number of trees, like changing the depth of those trees. By making some changes to those hyperparameters, what happens is the accuracy of the model also improves. But that is only 20%. 80% will be about like what you are trying to do on the data set. So this is how the accuracy looks like it's quite good. So now what are all the next steps? So now we have used a random forest in order to solve a classification problem. What I want you to do is next pick up an example which is an regression problem, and then you need to use random forest for regression and then see what happens. What will be the difference? So the implementation will be exactly same. The only difference would be, so here we are using the package random forest classifier. Whereas in case of regression problem, what we will be using is we will be using random forest regressor. So here in this particular line, random forest classifier. So instead of classifier, we will be using the package that is suitable for the regression problem. So that will be the only difference in terms of implementation. But what needs to happen is you need to put the effort in analyzing the data, as well as you need to put an effort in order to tweak various parameters. So in case of regression, the hyperparameters will be slightly different as compared to the classifier algorithm. So you need to make those things and then see what happens. So the assignment for you would be to implement random forest for a regression problem. Like try to get any data set from title that can be used for a regression problem, and then use a random forest for regression, see how good your model is. And then some of the learning material, like if you want to understand about the hyperparameters, how to tune the hyperparameters in order to improve the accuracy of the model. So this is a blog. I found it really helpful. It helps you to understand what are all the various different hyperparameters and how to tune each one of them to ensure that the prediction results are really good. And the next one is the next article talks about what are all the different methods that can be, or different techniques that can be used in order to improve the accuracy of a random forest algorithm. So I found both these articles really good. So what I would suggest is go through these two articles. I will be providing the link of these articles in the description. And along with that, what you can try to do is you can try to spend some more time, read about random forest algorithm, learn about various hyperparameters, why it can be used, in what scenarios, what type of hyperparameters needs to be used. So that helps you in understanding the algorithm much better, and hence it will keep you in a much better position to choose various hyperparameter next time when you are going to use the random forest algorithm. So that is it for today. If you have implemented random forest for regression, please share your script to me in the comment section. Maybe you can upload your scripts into a Git repository and then share the link to a Git repository. That will be very helpful for other people who are trying to learn and implement random forest for other problems. So that is it for today. And if you like what I'm doing here, please give a thumbs up and subscribe to my channel if you haven't so far. And if you think this video might be helpful for any of your friends, please share it with them as well. And that is it for now, and see you soon in the next session. Bye.